Hello and welcome back guys to another Alpha Math video. In this lesson we're going to be focusing on the linear function. Okay, so we'll start off with the general form of the linear function, which always starts with fx equal to mx plus c. Now you want to go ahead and click all to activate the sliders. Okay, so m is your gradient and c is your y-intercept. Now remember, the gradient tells us how steep the line is going to be. So if you have a gradient of 1, it means your angle of inclination would be about a 45-degree angle. In fact, exactly a 45-degree angle. Now watch what happens as we increase the gradient to a value greater than 1. Notice how the line is getting steeper and steeper and steeper. And notice when we decrease the gradient, how the line becomes more shallow. And in fact, when we go past 0, in fact, let's first have a look at when the gradient is 0. So when m is 0, when the slope of the line is 0, we have a flat line. When the slope of the line is less than 0, the gradient less than 0, we notice the line goes down, right? It's a decreasing line. Okay, let's bring it back to 1. Now, I want to show you what happens when we alter c's value. Keep in mind, I said c was the y-intercept. So if c's value increases greater than 1, notice how the line moves up. And when it decreases, notice how the line goes down. Okay, so that's what c does. C could either move the line up if it's positive or down if it's negative. Okay, I want to show you some other translations that can also happen to a linear function. And so let me add in a second function here. We'll go gx is equal to mx plus c. Okay, so notice now how this orange line, the gx line, is actually a copy of the fx line, which was the blue one. Okay, we can see they are exactly the same function. One is blue, the other is orange. At this point, they have the same gradient and the same y-intercept. Now, I want you to see what happens when I add some constant k to the function. Okay, let's add a k variable to this function. Okay, now I've added some value k to the function, and at the moment k's value is still equal to 0. But watch what happens as we increase this value for k. Notice how the line moves upward, and as we decrease this value for k, notice how it goes down. Okay, so when you increase it by 1, let's say k's value is equal to positive 1, you can see that the line moved exactly 1 unit higher than the previous function, the blue one. Okay, and notice when I move k to negative 1, so if we have this function mx plus c and we minus 1, the orange line goes 1 unit below the blue line. Okay, you see that? 1 unit below. Okay, what if I didn't add the k value to the mx plus c part, but rather added it only to the x value? Let's see what happens then. So I'm going to get the plus k out here, and let's put it next to the x. Okay, again, the two lines will be on top of each other right now because k's value is still 0. But watch, as I increase k's value, the blue graph, or rather the orange graph, will move to the left while the blue graph is still stationary. So we're going to move the orange graph to the left by increasing k's value. You see, I'm moving, or the graph is moving to the left as k's value increases. And notice if I put k's value on positive 1, we can see that the graph moved exactly 1 unit to the left. You can see the x-intercept is at negative 1. Let's adjust k's value to 3. Notice how the graph moved 3 units to the left. Okay, and so on and so forth. For any value of k, the graph would just move according to that. Now, if I put k on the negative side, perhaps negative 2, notice how the graph now moved 2 units to the right. Okay, so when you add, or rather, when you subtract a certain value, the graph actually goes to the right, and when you minus, and when you add, it goes to the left. Okay, I hope that made sense. So now you know what k does when you're adding it to the entire function, mx plus c, and when you're just adding it to the x component, and what that basically does to the graph. Now let me go ahead and show you some other transformations such as reflections. Okay, notice right now we have the standard function mx plus c where m is equal to 1, and let's adjust c also to 1. So this is 1x plus 1. Okay, this is the equation of gx and fx at this moment. Now I'm going to transform fx by reflecting it about the x-axis. And the way how I do that, simply apply a negative value to the y value of the function, or apply a negative to the entire function, so the mx and the c. We just multiply that whole thing by a negative, and notice now how this blue line is a reflection of the orange line in the x-axis. If you think of this x-axis as your mirror, then the blue line is a reflection of the orange line in that x-axis line. And we can also apply a reflection in the y-axis if we simply apply a negative value to the x. So now notice how the blue line is also a reflection of the orange line, but this time in the y-axis and not the x-axis. I want you to see the difference. So have a look at this image. Now compare this to the previous one. Okay, I hope you can see the difference. This is a reflection in the x-axis, and this is a reflection in the y-axis. Alright, that's all for now.